Hello everyone, and today the topic of my video assignment is Introduction to Hydrographs and Flow Duration Curves. Hydrographs and flow duration curves are powerful tools used in water resources management to understand and analyze the behavior of water bodies. These graphical representations provide valuable insights into the temporal and seasonal variations of stream flow, aiding in the planning, designing, and management of water infrastructure and water-related projects. Defining the hydrographs, what are they and how are they constructed? Precipitation. Hydrographs depict the relationship between precipitation and the resulting stream flow over time. Stream flow, uh, they show the volume of water flowing through a specific point in a river or stream, typically measured in cubic meters per second, which is denoted by m cube per second or divided by s. Time is hydrographs are plotted with time on the x-axis, allowing for the analysis of flow patterns and response to rainfall events. Understanding flow duration curves, purpose and application. Purpose. Flow duration curves depict the relationship between the magnitude and frequency of stream flow, providing insights into the reliability and variability of water resources. Application. They are used for hydropower planning, water supply management, flood risk assessment, and the design of water infrastructure such as dams and irrigation systems. Factors influencing hydrograph shape and flow duration curves. The three main factors influencing the hydrograph shape and flow duration curves are climate, watershed characteristics, and human influences. Climate, precipitation patterns, including rainfall intensity and frequency, significantly impact the shape of hydrographs and flow duration curves. Watershed characteristics, factors like soil type, vegetation, and topography affect the rate of surface runoff on and groundwater recharge, shaping the hydrograph. Human influences, land use changes, um, water withdrawals, and the construction of dam and reservoirs can alter the natural flow regime as reflected in hydrographs and flow duration curves. Here in the given diagram, we can see the flow duration curve. Here we have the storm runoff and normal base flow. Here the x-axis is denoted by the time and the y-axis is denoted by the precipitation. Here we can see there is a peak rainfall which will cause in the lag time due to the rainfall, and we have a rising limb and a falling limb and a peak discharge time and approach segment, and we have for 2 days over here, that is from afternoon 12 o'clock to night 12 o'clock, which is just half, and the next is a full day, that is from the midnight 12 o'clock to afternoon 12 and again midnight to complete one full day. And this is how the hydrograph is depicted, and the curves and the shape flow and duration. Interpreting hydrograph characteristics and flow duration curves. Hydrograph characteristics, key features like peak flow, time, time to peak, and the shape of the rising and falling limbs provide insights into the watershed's responses to precipitation events. Flow duration curves, analyzing the distribution of flows such as the percentage of time a certain flow is exceeded, helps identify water availability and reliability. Now here, as in the before slide and the diagram, we have just seen what are the different factors present in the hydrograph, but here we are going to understand them. Here we have the rainfall, the curve, and groundwater or basewater flow, lag time, peak discharge of flow, channel precipitation and overland flow, rising limb, recessional limb or descending limb, and through flow. So now groundwater or base flow, the main supply of water to the channel under normal conditions. Lag time is the time between the height of the storm, not the start or the end, and maximum flow in the water. Peak discharge of flow, maximum amount of water the river has a result of storm water. Channel precipitation and overland flow shows the flow of overland water. Rising limb, this shows how quickly flood water begins to rise. And recessional limb or descending limb shows the speed of water level decline or drop after its peak. That is the peak discharge of flow. And thorough flow, water passing through gaps in the soil, is the thorough flow. And this is how you interpret a hydrograph, and the flow duration and everything is what is here. And hydrograph analysis and it's important in water resource management, flood forecasting, water supply planning, and ecosystem management. Flood forecasting, hydrographs aid in predicting the timing and magnitude of flood events, enabling proactive measures for flood mitigation. Water supply planning. Flow duration curves help determine the reliability and availability of water resources for municipal, agricultural, and industrial use. Ecosystem management, understanding the natural flow regime through hydrographs, the flow duration curve is crucial for maintaining healthy aquatic ecosystems. And then practical applications of hydrographs and flow duration curves, hydropower, irrigation, flood control, and environmental flows. For hydropower, optimizing hydropower generation by analyzing flow patterns and availability. Irrigation, designing and managing irrigation systems based on water supply reliability. Flood control, informing the design of flood control structures and emergency response plans. Environmental flows, maintaining healthy aquatic ecosystem by ensuring environmental flow requirements. And conclusions, powerful tools, diverse applications, and informed decision making are the key takeaways of this topic. Powerful tools, hydrographs, and flow duration curves are essential tools for understanding and managing water resources. Diverse applications, they have a wide range of applications in water infrastructure design and flood management and ecosystem conservation. Informed decision making, analyzing these graphical representations can lead to more informed and effective water resource management decisions. Thank you, and that's it for my video assignment.